Find the maximum water height in meters. In this problem, two bodies of water having different water surface elevations are separated by a known distance. The dividing landmass has a known hydraulic conductivity and experiences a constant recharge. Darcy's law states that flow rate through a soil is equal to the hydraulic conductivity times the gradient times the total area. From a one-dimensional perspective, the average recharge rate, W, is equal to the flow rate divided by the area. This term is then substituted into Darcy's equation, and both sides are divided by K, the hydraulic conductivity. After skipping a few steps, the gradient is rewritten as the sum of the partial gradients in the vertical and horizontal directions. Assuming flow at the soil-water interface is purely horizontal, the partial differential equation is simplified by excluding the vertical component. The expression is then integrated with respect to x, and the constants of integration are solved using known boundary conditions. If we set x equal to the horizontal distance from the left bank in the direction of the right bank, and we set h equal to the vertical distance up to the groundwater table, the first boundary condition will be x equals 0, h equals h1. And the second boundary condition will be x equals L, h equals h2. Finally, the height of the groundwater table as a function of x equals the square root of the quadratic, shown here. For the given data, we know h1, h2, the recharge, W, the hydraulic conductivity, K, and the length, L. But the value of x is unknown. Since the problem asks to find the maximum height of the groundwater table, we need to find the value of x, which corresponds to the maximum height. At the groundwater divide, the slope of the groundwater table is 0. Therefore, we can differentiate our equation for the height of the groundwater table with respect to x. Set that value equal to 0 and solve for x. Doing so will calculate the value of x corresponding to the maximum groundwater height, h max. The known values of L, K, W, h1, and h2 are plugged in, and we compute the horizontal distance from the left bank to the groundwater divide to be 113.2 meters. Now that we know the appropriate value for x, it can be plugged into the equation for the height of the groundwater table in addition to the other known variables. And the maximum groundwater height equals 17.78 meters. Looking back at our possible solutions, the answer is B.